A very good afternoon, everyone, and I wish you a very warm welcome to the introductory webinar of Parametricism 1.0. I hope you all are healthy and well. I am Mehul Jain, an architect, a computational designer, and an educator in the domain of computational design and parametricism, and the founder of Epoch India, which is an architectural and branding service for aspiring individuals who need value and branded experience for their estates. Experiencing and analyzing the existing pattern in the domain of architectural education, I feel that there is a void for computational design in the architectural curriculum. And I feel that this void is due to two major primary constraints. The first being the constraint of the existing methodologies, the existing conditions, the existing knowledge and customs that we practice in our architectural education system and as well as in the architectural practice. And the second is the lack of limited tools, or I would rather like to say the limited exposure of the sophisticated tools used for computational design technique. But my interest in the subject has driven me to take initiatives and take parts in workshops like Smart Labs and other parametric design workshops and learning under tutors like Arturo Tedeschi, Mohammad Yazdi, who is the founder of Parametric House, and Sushant Verma, who is the curator of Smart Labs 3.0. Over the past couple of years, I have been engaged in these workshops and had led a research in the same domain of computational design and parametricism for a Hyperloop project, which allowed me to develop the required skill sets of the domain. Now, as an initiative to introduce the subject to the future architects, we have introduced a branch, Epoch India Education. So it's for architecture students, designers, and young professionals who aspires to acquire computational design skill set. Epoch India Education is an online education program which aims to fabricate the foundation of computational design skill sets. So with that said, I would like to begin the first introductory webinar of Parametricism 1.0. Now just share my screen. I've created a small presentation, after which I would focus on the Grasshopper tutorial. So yeah, starting with the session plan for today, I would just give a brief introduction of what computational design is. Then we would move forward to a basic interface of the Rhino 3D software. But our main focus would be on the parametric tool of Grasshopper, and we would be uncovering tutorials which would be focused on unrolling basic geometries, following which I would give a brief description of what Parametricism 1.0 is and what are the workshops that I've planned for the future, and ending with the Q&A session. So before directly jumping to understand what the computational design is, I would first try to take give an understanding of why we actually need computational and parametric design approach in architecture. Now, there has been a drastic change in the way we function, in the way we live, in the way we communicate, in all perspectives of our life. And if I give you a prominent example that we all can relate to is in the domain of communication. At initiation, we had systems like postal systems, we had telephones, we had typewriters through which we communicated. Then it evolved to televisions and radios. And now we have personal computers and cell phones. Cell phones has itself evolved into smartphones, which consist of different channels where we can learn information. Channels like Facebook, Instagram, and specific news channels where we can actually learn information. So this prominent evolutionary change in the way we live, in the way we communicate, in the way we function is due to a primary force of evolution of technology. But has it been the same in the perspective of design and especially in India? Now, this is the technology adoption life cycle in which there are actually 5 stages. The first stage is of the innovators, which comprises of 2.5% of the population. This group actually tries to innovate and develop new things, new technologies. Followed by this work are the early adopters, which comprises of 13.5% of the people. These people actually help the innovators and join those innovating technologies at a very early stage and help the technology to develop. Then we have early majority and late majority, which comprises of 34% and 34% respectively of the people. And these are the people who actually test the technology which has been developed or which has a minimum viable product to the market so that we can use those technologies and take the benefits from it. And at the end, there is a category of laggards which comprises of 16%. And these are people who many a times neglect these technologies or are unaware of it or do not interest themselves that much to be a part of it. So in the perspective of design, the timeline of technological evolution of design practice and architectural practice in India has been very different from the global use of technology in design thinking and architecture. Global leaders like Zaha Hadid, Norman Foster, Barack Ingalls are actually in that first stage of the technology adoption lifecycle where they are developing and using computational techniques not only for designing or drafting but also for visualization and fabrication. But in India, most of the architects and students are in the 2D drafting era where they are using computers only for drafting but not for designing. So I would ask you at ask you to ask yourself at which stage of technology adoption life cycle are you? Now, this has led to a long continuing general problem in the process and in the workflow of majority of students and we as architects. So to understand this problem, let us first understand the workflow. So suppose you got a design brief to design a specific typology of building. So what is the first step as students and architects we do? We gather information. And this information is related to site, like site locations, site conditions, surroundings, climatic conditions, sensory aspects, geological and topographical data, and many other things. Now, all this information that is related to a specific site is an objective data. And when I say objective data, I mean that it is something that can be measured and has specific values and which cannot be manipulated based on one's feelings and experience. Now, after gathering this information, we proceed to the second step, which is the processing step, in which we use specific design approaches, we use conventional methodologies, we interpret the data, and we use experience and the existing design culture to give a design output. Now, in this second step, where we use our feelings, we use our intuitions, we use our experience that we have gained from the past years to give a design output. So in this second step, there is a subjective translation to the objective data that we have gathered in the first step. So when I say a subjective translation, I mean that we are using our existing experience and our intuitions to solve a design problem. And this gives an output based on differential design approach, and it can differ based on experience and design culture. And there's a loss of data from the second step to the third step while we are providing this output. So for example, if suppose we are designing a specific facade for any given building, so if we gather information that is related to the amount of heat that a facade is gaining in all the four directions, we can actually calculate the hourly heat gain throughout the year on that facade at the first step. But when we move to the second step, we actually generalize this data according to a specific site on which we are working, and we actually do not use the specific objective data that we collect in the first step to give a design output. Now this can only be solved through a system of digital framework and a computational approach which uses a system of parametric model, and we have the possibility to have multiple iterations to select from in our third stage, which gives a design specific objective design output where there is no loss of data, and we can actually test before the execution of design. So for the previous example, if we need to design a specific facade, so we know we have the parameters like the length, like the height, and the window ratio of the particular side of a facade, and we can actually map using computational techniques that how much that particular facade in a particular direction is absorbing the heat, and what is the optimum amount of opening size we require for that particular site so that our design output is very efficient and very effective, which gives a specific and efficient design solution. Also, the major constraint, as I talked about, is in the architectural practice and the systems that we are accustomed to, the prevailing knowledge, the customs, the methodologies, and secondly, the limited exposure to the sophisticated tools. While we have access to a lot of tools related to data capturing, conceptual modeling, data management, visualization, our knowledge domain in the field of parametric modeling softwares and its environmental analysis softwares like Grasshopper, Flux, generative components, and the environmental analysis softwares which comes in as a plugin of Grasshopper like Ladybug, Honeybee, Millipede, Fox, which is used for fabrication techniques, is limited. Now, if we browse through the history of these buildings, we could realize that from the beginning of the earliest civilization to designing a vertical city in Shanghai, from the Roman architectural style to the modernist approach by Le Corbusier, to highly ornamented buildings in the Baroque period, to the computational approach by Zaha Hadid, the one common thing between all these structures is that everything is designed based on some parameters. Now, there was an unconscious use of parameters in different areas of architecture to fulfill specific human needs in different time periods. The only difference lies in the way these parameters are used then and the way it is used now. So it varies from a basic purpose of shelter to achieving a multi-purpose space, depicting power and supremacy through architecture to a modernist approach, using extensive ornamentation in forms to depict wealth, to manipulation of geometry using algorithmic expression. So the difference lies in the way it is put to application. Earlier, the parameters were somewhat more philosophical, but now along with philosophical parameters, we have mathematical parameters which actually guides the formation and the forms of specific typologies of building. Now, coming to understand what computational design is. Computational design is the process of practicing design activities through application and development of novel ideas through the use of computers. In simple language, it is the application of computational technique to the design procedure. Most designers nowadays rely on intuitions and experience to solve design problems, but computational design aims to enhance that process by encoding design decisions using a digital framework and a system of parametric modeling framework. So parametric design, generative design, algorithmic design, evolutionary optimization, computational analysis, form finding, machine learning, self-organization. These all are the subparts of the greater domain of computational design. These are somewhat similar to each other, but has their unique differences and applications in the domain of computational design. Like parametric design uh, is based on the mathematics and the parameters that we use to guide a mathematical function. Generative design in brief would be the possibility to generate multiple outputs using these parameters that we set in the parametric design approach. And similarly, we have evolutionary optimization, computational analysis, form finding techniques using computational approach, self-organization. For an example for self-organization, I can give you the pattern that a flock of birds follow while flying in the sky. So there's a mathematical approach followed by these birds, which is based on this self-organization technique, in which they follow the surrounding three birds and maintain a particular position while they are flying in the sky. Now, moving on to the benefits and understanding the benefits of computational design. The first, that it gives us the possibility to generate many multiple design solutions based on specific parameters to give an optimum output. Then computational design makes it possible to create bidirectional links between different tools to inform design, like it enables us to link our conceptual models to our parametric models, to the fabrication models and the environmental analysis models, and allows us to actually access data from all the different platforms and to give an effective output. It also speeds up the process to automate repetitive tasks like copying, renaming, creating own tools that work smarter. It gives the possibility to stimulate building performances based on a given set of conditions and helps me optimize the process, the design process, and we can actually test our design before executing it to check how a specific typology of building is actually performing in that specific conditions. It forces a person to think algorithmically and in a sequential manner without actually relying on intuitions and experience to solve design problems. Now, understanding how most of the computational designers actually use this technology. So we have two things. One is the visual scripting platforms, and another is the traditional text-based scripting platforms. Visual scripting helps us assemble graphically rather than writing codes, which can be tough. And we, as a designer, do not have that ability to write codes. So there's a platform. There are many platforms where we can actually visually script, and this results in a graphical representation of the steps required to achieve the final goal. Now, there are many tools available for visual scripting like Grasshopper, which works seamlessly with Rhino. We have Dynamo, which is a plugin for Revit. We have generative components, which works with MicroStation. Then we have Flux, which is an initiative by Google's research lab, Google X. But evidently, from all these platforms, Grasshopper has been a leader amongst these platforms, and hence our focus would be on Grasshopper, which is the most popular computational design tool, and it works with Rhino, which is a 3D modeling software developed by Robert McNeil and Associates. So, by saying this, let's start our computational designer journey, and let's explore. So I would request everyone who has downloaded the Rhino software to just open the Rhino software, or else you can just see the tutorial and see the webinar, and you can apply this later on. I would just reshare my screen. Yeah, so is my Rhino 6 screen visible?
Yes, it's visible, Mehul.
Okay. So I will just give a brief overview of what Rhino 6 is and how it interface actually works. So Rhino is like any other 3D modeling software like 3ds Max or SketchUp. So to give a brief overview, we have 4 viewports in the Rhino space. This is the working space. So this is the perspective viewport. We have the top viewport, which has the XY plane. This is the front viewport, which has the XZ plane. And this is the right viewport, which is the YZ plane. All this top, front, and right viewport are two-dimensional planes, but the perspective viewport is the 3D modeling space where we can actually see our geometry in 3D. So to maximize this viewport, we can just double click this perspective icon and the viewport gets maximized. If you want to pan to different viewports, there's an option for panning through different viewports at the bottom left screen, where you can go from perspective to top, to front, right, and back to perspective again. To see all the four viewports back again on the screen, you can just double click this again and we can have all the four viewports back again. At the top, we have the menu bar in which we have these files, edit, view, surface toolbar options, curve toolbar options, solid options. So we can select these options to make any geometry in the 3D modeling space. So Rhino is very similar to AutoCAD. Like we have a command box at the bottom screen in the CAD interface. The command box in the Rhino interface is at the top of the screen, where we can actually write commands to make any geometry. Below that command toolbar, we also have different tabs for specific tools. Like we have tab for surface tools, we have tab for curve tools, rendering tools, drafting tools, mesh tools. Also, there's an option for help in which you can find basic learn Rhino tutorials, and I highly encourage you all after this session to go through these tutorials, which would give you a brief introduction in detail of how the Rhino 6 interface works. But for now, today, due to we have limited time, I would just show you how to make simple points, curves, and surfaces on Rhino, and then we will quickly move on to Grasshopper, which is our main focus for today. So for now, I will just maximize this perspective screen. And if I go to the standard toolbar component, there is multiple options to make points, lines, curves, surfaces, primitive solid shapes. So let's start with making a point. Okay, before starting this, just I would like to know that how many participants are actually working simultaneously on the Rhino 6 platform along with me. So you can just write in the chat box and I would come to know. Okay, so we start with making simple points. So if we go to the standard toolbar component, we can make multiple points or single points depending upon. So if you see there's a small little triangle made below this point. So if we click this, we can actually see there are two options. If we click the left mouse button, we can make a single point, and if we click the right mouse button, we can make multiple points. So let's make point. So as soon as I select that, we can make multiple points on the 3D modeling surface. To make lines, we can write line in the command toolbar and press enter. It asks for a start point and an end point to make a particular line. We have options to create basic NURBS curve. So NURBS is non-uniform B-spline representations. Similarly, we can make interpolated curves, which actually interpolates a curve on the points we select. So there's a basic difference between a NURBS curve and an interpolated curve. So if you see, when I select NURBS curve, and when I start selecting and making a NURBS curve point, the start point is the start point of the line. But when I select the next points, these points are actually becoming the control point of the NURBS curve. So when I press the last point and I press enter and I select this curve, you see all these points are lying outside the curve. And these points are actually the control point of this curve. So if I select this again, I select this particular point. So whenever I select anything, this is an axis which comes along, which is called the gumball, and we can use this to manipulate any geometry. So I can move it in the x direction. The red arrow is the x direction. The green arrow is the y direction. The blue arrow is the z direction. We can also rotate in these axes using this curve. So I can rotate these points. And if I show you how our interpolate curves work, so when I try to make an interpolate curve, so when I'm selecting the points, the curve is actually getting interpolated at these points. So this is the basic difference between an interpolated curve and a NURBS curve. Now we can also make surfaces from this panel, which is specifically for surfaces, or we can go to the surface toolbar over here to make surfaces which have many options. I encourage you to try and work with these options after this workshop. But for now, we will just go to this surface. We will try to make surface from planes and choose corner to corner option to make a simple surface. So this is a simple surface. Now by default, Rhino interface is always in a wireframe mode. To change the mode of this, we can select this little triangle, which consists of many different screen modes. So I can go to the shaded mode. So this is my shaded mode. We can go to the rendered mode. This is my rendered viewport. Now whenever I make a surface, that if I go back to the shaded mode, the top side always comes as this gray color and the back side of the surface comes as a red color. So this is the depiction and understanding, which is the front side and which is the back side of a surface. We can also make primitive shapes like a solid box using this. And if we go to the rendered viewport again, This is something which looks like a solid box. We can make spheres, and we can explore with many different typology of geometries which is primitively existing in the Rhino interface. But for now, we will stick to this for the Rhino because our main focus is on Grasshopper. So I will quickly erase these all and move to Grasshopper. So Grasshopper is a direct plugin for Rhino 6 interface. And if you have installed a previous version of Rhino, so you have to separately switch on your Rhino software. But first I will just go to new and create a new file. So whenever we create a new file, Rhino gives us different preferences and of metric system in which we can work. So as architects, we always work in millimeters. So I select this small object millimeters and I click open. So you see by default, it always opens in a wireframe viewport, and I maximize the 3D modeling viewport. Now to open Grasshopper, we just write Grasshopper in the command line and select this. So this will run the Grasshopper component and my Grasshopper interface gets opened. So this is the Grasshopper interface, and whenever you open Grasshopper, you can open your previously done files, or you can just go to file and you can create a new document. Now Grasshopper is a visual scripting platform. So in this, you actually can visually script, and the output of this visual scripting is seen on the Rhino 3D interface. So whatever we script in Grasshopper, we can see its output in the Rhino screen, in the Rhino perspective 3D modeling space. So it is suggested that we split our screen between the Grasshopper interface and the Rhino interface in half, so that we actually can script and simultaneously we can visualize the things that we are scripting in the Grasshopper interface. But for now, I will just maximize this viewport to make you understand what the interface is like. So this is the workspace where we actually script. At the top, we have the menu bar from where we can open new file, we can create new files, we can save the documents, we can access to special folders in which our different plugins actually get saved, like Ladybug and Honeybee, which are environmental analysis softwares. We can go to edit, we can change the view system, we can change the display system, and at the end there are few files which are the tutorial files, and I highly encourage everyone after this webinar to go through these files, which will give you a overall introduction to the Grasshopper interface. Below this menu bar, we have this component toolbar in which we have different components. Like this is the surface component tab, and under the surface component tab, we have specific toolbars like primitive, which is used to make primitive shapes like cones, cylinders, spheres. So this is the component tab. These are the toolbars, and under these toolbars, we have specific components. So like curve is the component tab. Primitive, under curve, primitive is the toolbar, and under primitive, we have these little components. So for example, if I select this line component and I drop it in my workspace, this is the component which starts running, and it needs an input and it gives an output. So every component by default, suppose, sorry. So this is the component, and the first part of the component is where we actually give an input. The center part depicts the name of the component, and the last part gives an output. and this output can be visualized in the Rhino screen. So for example, okay, before moving to the example, I would like to say that there are three types of components. The first is a standard component. So standard components are something which requires an input to give a specific output. So by default, all the components in the Grasshopper interface are standard components, except in this params tab, the geometry toolbar, the primitive toolbar, and the input toolbar. Except these three toolbars, all the components in the Grasshopper interface are standard components. That is, it requires an input to give an output. The second type of components are input components, which can be accessed through the params component tab under this input toolbar. So we have many components like number slider, panels, boolean toggle, button, and many more. So input component is basically a component which gives only the output. It does not require any input, but this component is used to give the input to the output. So for example, I go to a number slider and I select number slider from this params tab, the input and this number slider, and I drop this on the Grasshopper screen. So this is a component which is actually used to give a output to any other component, and it does not require any input. Another example is like Boolean toggle, which is used to set true or false condition to any component, and we have many others. The third type of component is called a container component. So container component contains a specific geometry that is made in the Grasshopper interface, or we can reference it using in the, that is a geometry that is made in the Rhino interface. So suppose this is your Rhino interface and you made a surface in the Rhino interface. So you can use this component, which can be found in the params toolbar, params component tab, in this geometry toolbar and this primitive toolbar. So if I choose this point container component, so you see this component can actually store a set of multiple points which has been defined in the Rhino interface. So for example, if I make one point in this Rhino interface and I select this point container component, I right click it, there's an option to set one point. If I click this and then I go to the Rhino interface and I select this point, you see this point has now been referenced in the Grasshopper interface, and the color of this component has turned from orange to gray. This means the component is now working perfectly fine, and the point has been stored in this point container component. So all these container components are found in this params component tab under this geometry toolbar and this primitive toolbar. So I will erase this for now and delete this once again. Yeah, now we will start making a single point. So like AutoCAD and Rhino, whatever we need to do, we suppose we need to make a line. So we write line in the command box and it makes a line. Similarly in Grasshopper, if we want to make we want to make anything, we just write that thing, and pretty much that would be the name for doing that particular task. So suppose if I want to construct a point, so I can just go to this curve option, vector option, sorry. So in the vector component tab, we have a toolbar for points, and in this toolbar, I have an option for construct point. So if I select this and I drop it over here, so this is the component tab to creating a point in my Rhino interface. So by default, the input for x, y, and z coordinate for this component has been set to world 0, 0, 0. So you can see whenever I choose this component, it gives an output in my Rhino interface screen. That is this one. So if I select this, it becomes green in my Grasshopper interface, and its related output becomes green in my Rhino interface as well. So by default, XYZ is set to world 0, 0, 0. And if we now need to change and parametrically control this point, we have to give inputs to this X, Y, and Z coordinates. And this input is given using the input components. So there is the four ways in which we can actually set the data. The first way is by local setting. So local setting means we can just zoom into this component. We can move our cursor over the X coordinate. We can right click this. We can go to set number and we can change this number. Suppose 5. So this moves 5 units in the X direction in my Rhino interface. So you see, you can count 1, 2, 3, 4, 5. It moves 5 units in the X direction. Similarly, I can move and set a number in the Y direction, suppose 10. So it moves 10 units in the Y direction. And I can set a number for the Z. So it can also be negative number. So for example, we set minus 15. So it moves minus 15 in the Z direction. So it's below the Cartesian plane in the modeling surface, and the point is made at 5, 10, minus 15 in the XYZ coordinates. The other way to open this construct point tab is by double clicking your mouse in this Grasshopper interface, and it opens a command box in which you can actually write construct point, and you can select this component. And now again, because by default we have X, Y, Z set at 0, 0, 0, you can see there is another point which is visible at the selection at 0, 0, 0. The second way to set data in the X, Y, and Z coordinates is using these input components. So we will set data first using a number slider. So you can choose a number slider from Params tab, input toolbar, number slider, and drag and drop this over here. Now by default, a number slider has a domain of 0 to 1. So whenever you open a number slider, it has a default domain from 0 to 1. But suppose you want a number greater than 1 in the X coordinate. So you can just click this, right click it, go to edit, and this toolbar appears in which there are many options. You can change the name. Suppose if I use this for X coordinate, I write X coordinate. There's an option to change the rounding. So by default, it's set to 3. We can change it to 2, 1, 0 or more. We can change it to be just integer numbers, so the rounding gets over. We can set it to be just even numbers. We can set it to be just odd numbers. For now, we will set it to be integer numbers. And this is the numeric domain where we can actually set minimum. That is, suppose, let's say 0. We set it the minimum to 0. And we can also set maximum. So let's set the maximum to 100. Okay, and then we click OK. So now the domain of this number slider becomes from 0 to 100. So if I zoom out a bit, you can see now I can parametrically control this X coordinate of this specific point using this number slider. So for example, I want to set it to, let's say 20. So I write 20, okay, and my component is set at 20. Similarly, when by default we choose a number slider, it gives a 0 to 1 domain. But if you double click and this dialog box appear, which is the command tab, And as soon as we start typing a number, you see by default, whenever we type a number in the command box, it converts it into a number slider. So for example, if I write 10 and I press enter, it makes a number slider with 10 as my end and 0 as my domain, as my minimum value, and it makes a number slider starting from 10. But for example, if I want to set a specific minimum value, a specific starting point, and a specific maximum value, I can just type, for example, let's say I start from 0, then I can type less than. I want this number to start from 25, so the initial value is 25. Again, less than, my maximum domain should be 100, and enter. So this creates a number slider whose domain is from 0 to 100, starting from 25. And I can directly change the name of this number slider using right click. I can go here, I can type Y. So this is the Y coordinate. And I can just select this white button and give an input in my Y coordinate. So you can see now my Y coordinate is set at 25, and I can actually move this to control the Y coordinate. Similarly, we can set a negative number for the number slider going to a negative domain. So if I type minus 30 is less than, I want to start at minus 15 suppose, and the domain should end at 0, and enter. So the domain is now from minus 30 to 0, and I want it to be my Z, and let's set it at minus 15. So this is a point. The green point is the point which is set at 20, x, y 25, and z minus 50. I can change this name with set. Now the third way to set input data is using panels. So I would just create another point using construct point. We can also press spacebar, which opens this command box, or we can double click it, which again opens the same command box, and we can write construct point. Now panel can also be used to read output. So suppose the coordinates of these points is 20, 25, minus 15. So it made a point, and as an output, it gave the output of the coordinates. So x is 20, y is 25, and z is minus 15. And you can see when I change this, the output in the panel also changes. So now let us set it to 25. And the panel can also be used to give an input to any of the coordinates. So to write a data, just double click in the panel and write, let's say 30, and click outside, and we would reduce the size of this panel, and we would use to give this as an input. So it created a third point at x30, y0, z0. Now to create a panel directly without selecting it from the toolbar, we can open the command box, and we can use a quotation mark. So as soon as we type a quotation mark, it means anything that we are typing after the quotation mark will go into the panel. So suppose I write 40 and I press enter. So it created a panel which contains a data of 40, numeric value 40, and we input this in the y coordinate. So it made a point at x30 and y40. Similarly, panel can be again a negative number, suppose minus 50, and enter. So this panel has a value, numeric value of minus 50, and it gives that value of minus 50. So these are the three ways in which we can actually set data into any input of any component. Also, there is another way to reference a specific point which has already been made in the Rhino interface. So for example, I make a point in the Rhino interface and I move this point to give a z axis, z direction, a y direction, and x value. I make another point and move this in x, y, and z. Suppose I have these 2 points in my Rhino interface and I want to reference these 2 points in my Grasshopper screen. I can use that container component which is available in this params tab, going to geometry, and this is the component for containing data. So I choose points. Now to set these 2 points in this point component, I can just right click it. I can go to set multiple points and we can choose the first point, the second point, and click enter. So you see now it has referenced these 2 points in this container component in my Grasshopper screen. So if I move now in the Rhino interface, it automatically update in the Grasshopper interface as well. So my first 3 points are actually made in the Grasshopper interface and we can actually visualize it in the Rhino interface. And my last 2 points is made in the Rhino interface and I have referenced it to the Grasshopper interface. Now my first 3 points are only visualizations. So if I try to select this in the Rhino interface, you see I cannot select it because at this point, these points are only visualizations which can be controlled using these parameters of number slider or a panel. But if I want to bake a specific point from Grasshopper to Rhino, I have to bake this into Rhino. So suppose I want to take this point, which is at x5, 10, and minus 15 into Rhino and want to select this point in Rhino, we go to the output side of this component, we right click it, and there's an option for bake. So if I select this toolbox appears in which all the layers which are by default set to Rhino is visible. And if I select, suppose I want to bake it in layer 5, so I select this layer 5 and I select OK. So now what happens, you see a point appeared in Rhino and now actually if I select it, it's getting selected in the Rhino interface and I can move it. But this movement is only limited to the Rhino interface. You see the visualization is still remaining in the Rhino interface of my Grasshopper point. So this is just a visualization and this is the actual baked point. For now, I will delete it. Suppose you want to hide these visualization from the Rhino interface. So there is an option. You can just right click it. Oh, sorry. You can select this. You can press the middle mouse button, and this dialog box appears in which there is a human head with a ribbon. So this is used to disable preview. So we can select this, and this will disable the preview of the point. And to switch it on again, we can use this enable preview option and we can switch it on again. There are other things as well, like we can bake directly using this. We can also select all these, press the middle mouse button, and if you want to group this, there's an option to group it. So this option will create a group, and if we select this, you see we can make a group of all this. So if I select this group and I want to arrange my script so that it becomes green, I can directly select this color and I can rearrange it. So if anyone has any doubts in understanding how to create and reference point in Rhino and Grasshopper, you can just unmute yourself, or else I would proceed on understanding how to create lines. Okay, so we would proceed to make lines. Now to make lines, there is a component tab of curves in which there is a toolbar of primitive components in which we have this line option. So we can we can choose this component and we can drag and drop it over here. So you see, by default, when we try to create a point, we had default values for our inputs x, y, z set at 0, 0, 0. That's why the component was running perfectly fine and we had a gray color of the component. But in case of line, the default points are not set and we need to set these points, and hence when we dragged and dropped this line component, the default color was orange and there was a small balloon which says input parameters start point failed to collect data, input parameters endpoint failed to collect data. So we need to give an input. So suppose we need to make a line between the first point and the second point. We just input this point as our starting point and this point as our end point, and you can see we created a line in the Rhino interface. Similarly, you can open the command box by spacebar and you can write line. Now, when I type line, you can see there are two options for line command. Always remember that the black hexagonal box in front of any command, the icon of the black hexagonal box in front of any command means that that component is a container component. So if I select this component, we cannot actually make a line using this component because this is a component which can only contain a line. So if suppose I have made this line and I want this component to contain this line, I can give this input to this and now it contains that specific line. Or else I can make a line in Rhino and I can type line again. I use that container component. I can reference that line from Rhino. So you see, it referenced that line from Rhino itself. So this component is used to contain a specific line or multiple lines. But to create a line, you need to choose this. So if you hover your mouse over the components, you can actually read what that specific component does. So this component creates a line between 2 points. So we can choose this option, can delete this for now, this as well. Yeah. So now suppose we want to make a line from this point and this point. So you see it made a line from the first point to the third point. Now there are many other options. You can create NURBS curve, you can create interpolated curve. I already explained you what a NURBS curve is. So a NURBS curve, suppose you have this one point. This is another point. Sorry. So suppose you have this point, you have this point, you have this point, and you have this point, and this is your point number 0. This is your point number 1. This is your point number 2, and this is your point number 3. So what a NURBS curve does, it tries to create a smooth curve using these points as control points and using only the start point and the end point as the starting and the ending of the NURBS curve. But these points are used to actually control the curvature of this line. So if I try to demonstrate it, there's a component called NURBS curve. So we select this component. Okay, so before moving to NURBS curve, there's another option of merging a data. So what this component does, it merges multiple data. Suppose we have 1, 2, 3, and 2 points, which is referenced in this 5 points. So what this component does, it merges all the points in a specific given list. So for example, for now, if I read the output of this, it contains only 1 point. Similarly, this contains 1 point. This also contains 1 point. But this contains two reference points because I have referenced 2 points from in this point. But now if I merge this point, if I merge this second point, I get this input as the third point. So you see, by default, when I opened the merge component, it had input for only two values. But as soon as I inputted two values, it starts on adding data. So it's a never ending process. It can add as many numbers as you want. So I inputted the first three values and then I inputted the last two values. And now if I read the output of this, you see it gave me first point, second point, third point, and it coordinates, and the last 2 points in order of the reference. So if while referencing, if I choose this point first, so the index number of this point would be prior to the index number of this point. So this is the output as read in a list. So in Grasshopper, when we move forward in our later workshops, so what Grasshopper does, it make different trees to arrange data. So for example, if I select this again and I try to make a tree, so every data is set in trees which have different branches, and then every branches have different elements. So this is a concept I won't like to touch for now, but you just need to know that all the data is made in trees, which is subdivided into branches, which is then subdivided into different elements. So for this one, this is a specific tree which is divided into this branch number, which is the branch number is 0, which is again divided into these elements, which is called the index number. So the index number by default starts from 0. So the index number of the first point is 0, then the second point is 1, third point it is 2, and the last 2 points it's 3 and 4 respectively. So if I change the order while inputting this merge data, suppose I input my reference point as data 2 and my second point as the data 4, you see the output change. The first point remained the same, but my two reference point input, the index value of the two reference point changed, and then I had the third number, I mean the third point, and then the fourth point. So this is how a tree is being formed of a specific data, and it depends, everything depends in the manner in the order you are actually giving the data input. So for now, I would rechange it to give this data 2 and this as data 4. The output changed again. Now we would move to make NURBS curve. So NURBS curve requires 3 different inputs. The first is the vertices. So vertices are basically the points through which I want to make the NURBS curve. Then it requires a degree. By default, the degree of a curve is always set to 0. So I will explain you what a degree is. Suppose, one second. Yeah. Suppose I have this point. I have this point, and this point, and the last point, and I try to make a NURBS curve. So it would make something like this, where these points are controlling the curvature of this curve. Now by default, the degree of all the smooth curves is 3. And by degree, I mean degree is something that actually controls the smoothness of a curve. And by mathematical function, by default, to create the smoothest curve and the most flexible curve, the degree is always set to 3. So if you don't set the degree to 3, what will happen is this curve would actually start, suppose if I change the degree to 1, so the flexibility and the smoothness becomes 1, and the curve would be something like this. So it will create a straight line with this point to this point, a straight line from this point to this point, a straight line from this point to this point, a straight line from this point to this point. So it will make basically a polyline, which is not we want while we are making a curve. So by default, always set the degree to 3. You can change it to 2, but 2 will give you something like this, which is also not smooth as mathematical expression. So I recommend you to set it at 3. So I remove this for now. So it needs degree, and periodic is something which means that if you want the curve to be a closed curve or an open curve. So for example, I set these results as my vertices. You see it automatic. Okay, firstly I will switch off all the previews of these so that we can only visualize the latest NURBS curve that we made. So as soon as I inputted the vertices, it made a NURBS curve because the default value of degree is already set to 3. You can read it by hovering your mouse over the degree input option. You can see it says one locally defined value set at 3, and by default the periodic is set to false. And false periodic means the endpoint and the start point of the curve won't meet, and hence it would give an open curve output. But I can change this using an input of Boolean toggle. Okay, so if anyone wants to find where the specific component is, suppose I want to find, I don't know in which component tab my NURBS curve is, and I want to find it, I can just press Control and Alt together, and I can select this. So what this does is it guides you through the Grasshopper interface by arrows. So it shows the NURBS curves option is available in the curve component, a curve tab in the spline toolbar, and there's a component which whose symbol is something like this, which is for NURBS curve. So Boolean toggle can be found using Control Alt and selecting this, and it's in params tab, input component, and that is the icon for Boolean toggle. So by default now it's set to false. So if I input this and I change this to 2, you see it actually made a smooth closed curve. Now you see all these points, as soon as I made it true, are the control points, and the curve is actually lying outside these control points. And these curves give 3 output. The first output is a curve, so we can read this output. The curve is visualized in this 3D space, and it says that it's a periodic curve. So if I set it to false, it is a normal curve. True again, it says it's a periodic curve. It also gives the length. So when I start and give this input, you can see the first line disappeared and the second line just got inputted. But if you want both the lines and want the data of both the output to be displayed in this, we can just select this, and now by selecting shift and starting and ending it over here, you see both the lines got connected in this input, and we can actually read that the curve is a periodic curve and its length is 187 millimeters. Domain is something that I won't touch for now because it can get complicated, and it's directly related to the data tree structure, which would be covered in later workshops. So for now, we would just skip domain for curves, but I will surely touch what a domain is for a surface. But if you want to visualize it, you can again select shift and input it. So the domain for this curve is from 0 to 5. Similarly, if I want to make an interpolated curve as we made in Rhino, there's an option for interpolate. So as soon as we type interpolate, you see this tab is at the bottom and it wants four inputs, sorry. So the first inputs is vertices. So as soon as I inputted that, you see it made interpolated curve, which is now actually interpolated from all these points. And the degree again is by default set to 3. The periodic is set to false, and knot style is something that I won't cover for now. But by default, we never change the knot style. It is by default set to 1, that is chord spacing. So I recommend that you should leave that knot style to be 1. Now, to just understand how the degree works, let us input a value 1 to this degree. I will just switch off the preview for this interpolated curve. Okay, I will input it for interpolated curve and switch it off for knobs curve because it would be better understanding for interpolated curve. So if I input this degree 1, you see the degree changed the smoothness of this curve. It is now just like a simple polyline connected by straight lines. So degree is something which controls the smoothness of a curve. And if I make another number slider and I get 2 over here and I input this 2, you see it gave an error. Interpolation does not allow even degrees. So interpolate curves do not allow even number in degree. So, and by default, the best smoothness and the best flexibility of interpolated or any curve is given by 3. So we will set it to 3 or else we will remove it because by default it's set to 3. Now, one more thing, as we demonstrated earlier, if you change the order of this data input, the order of the output also change, and similarly the order of this interpolation will change. So suppose I input this second point as my last point and the last point as the data 2, you see the curve changed, and it changed because the input parameters changed. But for now I will revert it back. And I will create something like this. Now you can parametrically control this curve using these parameters. Like if I change this, you see the curve is also getting changed. So we are trying to generate something that is called a digital framework, or we are trying to create basically a parametric system of a parametric model in which we can actually control this final geometry with many different parameters. For now, this geometry has parameters like this, which has been directly referenced from Rhino, or parameters like the XYZ coordinates of these curves. If I change this, you see the curve is getting changed. I can also change this, say I set it to 50 and enter. Okay, so there is one thing that to remember: whenever you are typing in panel, never press enter, because what enter does, it takes you to a new line, and as soon as it goes to a new line and you click OK, you see it gave an error command, and whenever a component shows an error, it turns to red with a balloon and it says data conversion failed from text to number, and this is because there is a null value in the second line, and this is what is creating that error, and your second point is failed to be made, and hence it has failed to be merged over here, and my curve changed, and it changed to make just from these 4 points. So I have to correct this. To correct this, double click it again, go back and press OK. Now it works smoothly, and it again changed to a gray color. That means it is working perfectly fine. So this is the difference between a knobs curve and an interpolated curve. And if anyone has any doubts, if you are trying simultaneously in your screens and you are unable to make anything, you can just unmute yourself or you can write it in the chat box. Okay, so we can move forward. That's an error. I will create a new file. Small object will let us. Okay. I could just reference 2 points again. I will go to this point option. I will go to reference multiple points. Select this, enter. Now you see when I created a new model and I changed the points, the curve got changed. So now I will hide the knobs curve. I will manipulate this geometry a bit to give a better curve output. Okay, so we have something like this. Now let's make a curve in the Rhino interface and try to reference it in the Grasshopper interface. And then we will try to take those two curves and make a surface from those two curves. So for making a curve in the Rhino interface, I select interpolate. I make a. So now you can see since my ortho is on, so as it is done in CAD, I can switch off my ortho and I can make a smooth curve. I can use this gumball to give it a direction other than 0, 0, 0 and rotate it in X direction to give it a Z factor. Now I have made this curve, which is an interpolated curve in the Rhino, and to reference it in Grasshopper, we can go to geometry and we can go here. This component contains a collection of generic curves, and I can select this component. I can go to set one curve. I can go to the Rhino screen and select this curve and press enter. Now this curve has been referenced in my Grasshopper component. So I have this interpolated curve, I have this referenced curve, and now we will see how to make a surface from these two curves. So there is a component called loft. So what loft does, basically, suppose you have this surface, you have this another surface, and if you want to loft this curve from this curve, what loft does, it matches the start point with the start point and the end point to the end point and create many number of points in between these start and end points in a particular order, and it makes a smooth surface along this. So suppose this is the start point of my this curve and this is the end point of this curve. This is the start point of this curve. This is the end point of this curve. What loft does is it makes multiple points in between these start and end points in both the lines. And all these points have index number. So the index number starts from 0 to n number of points. So 0, 1, 2, 3, 4, 5, and so on. Similarly for this, 0, 1, 2, 3, 4, 5 till n. and it matches. It's the 0 point of this with the 0 point of this, the point 1 of this with point 1 of this, 2 with 2, 3 with 3, 4 with 4, 5 with 5, and so on to make a smooth surface. So this is what a loft command does. I will erase this, and to go to the loft command, we can go to surfaces, we can go to freeform, and there's an tool component for loft, or else we can directly type loft and enter. So this component wants two inputs, curves and options. Options is something which is related to rebuilding of surface, which we won't cover for today. I will just show you how to loft two curves. So suppose this is your first curve and this is your second curve. So it lofted because it is in the wireframe mode. Just 1 second. Okay, so this is a tab in which you actually can change the display settings. So this was a tab in which all my previews went off. This was a wireframe tab of the Grasshopper. So my previews were in the wireframe mode. And this is my actual tab in which I can actually visualize all the surfaces. So by default, it is set to this. I think I click by mistakenly into the wireframe mode. So click this red cylinder button to have a shaded preview of your geometry. So when you loft this curve to this curve, you see a surface something like this generated. So what it did, it matched the first point of this with the first point of this curve, and similarly it created multiple points on both the lines and did it till then to create a smooth surface. There's another component to flip this curve. So what this component does, suppose this is your curve which was actually made starting from this point to this point. So the direction of the curve is in this direction. So flip curve does what flip curve does, it changes the direction of the curve, and the start point becomes this and the end point becomes this. So to demonstrate how the loft will work if the direction of both the curves are different. So I input this curve into this curve. Now the output of this flip curve is a flipped curve of the initial curve, and I input this to this. Sorry, I first have to input this curve. Then using shift button, I have to input this curve. You see, it created a surface something like this. And this is because it lofted. The first point of the first curve was over here, and the first point of the inverted curve was over here. So it lofted from here to here, and it continued lofting till the end point from here to here. And this is what we get, and this is something we should avoid, because this geometry is something which will give an error and cannot be actually fabricated or is useless basically. So we have to remove this and we have to add this again. So this is a geometry. So if now I change the control points, you see, using these parameters, I can actually change the surface. So for this system, now we have so many parameters. We have this curve to play with to define a surface. We have these points of these curves to play with to define the parameters. We have the points of the first curve to play with to manipulate the geometry. And this is how a parametric model for basic shapes and surfaces and forms can be made. Now, there is one more thing. For now, I will just switch this off once again. And I will hide this using the hide command in my Rhino. And I will switch on the two lines that we made at first. So now suppose these are the two lines that we made this is the first line, this is the second line, and I want to make a line from the midpoint of these 2 points. So as I said, whatever you want to do as a function in Grasshopper, you just type it in the command box. So to make this line from the midpoint of the midpoint, so we need to evaluate, we want a point on this curve actually, on these 2 curves. So there's a component called point on curve. So you see, this is the component which says it evaluates a curve at a specific location. So I select this. So by default, the domain, which is the minimum number to the maximum number of this curve, is 0 to 1. So I set it to 0.5, say. So 0.5 means it's the midpoint. I input this to this, so it gives me a midpoint on this line. Similarly, I do it for this, which gives a midpoint for this line. And now we can make a line using the line component. Create this. So you see, we created a line from the midpoints of these 2 points. I will switch this back off again and switch on my lofted surface. So we can proceed further, but if you have any doubts, if any one of you can just let me know, or else we can proceed. Okay, so the next step, suppose this is a front surface for anything, and I want to divide this surface, like for example, let me sketch it out. Suppose I have this surface made in Rhino using Grasshopper parameters, and I want to divide this surface into smaller surfaces to create smaller frames in which I want to manipulate a geometry. Suppose I want to, okay, so first let's understand how to divide this surface into these smaller surfaces. So to divide a surface into smaller surfaces, there is a component called isotrim. So if I type isotrim, you can read it extracts isoparametric subsets of a surface. So it wants 2 things. It wants the initial surface, it wants initial surfaces, and it wants a domain. So the initial surface is this, and domain is something that I have to tell. Now suppose this is a graph, and I have a surface somewhat like this. I'm making a surface somewhat like this. This is the x direction, this is the y direction. But in case of a surface, the surface is always referenced in a local coordinate system. So x, y, and z direction is a world coordinate system, but the surface is always referenced in a local coordinate system. So for a surface, this direction is u, and this direction is v. And for example, let the domain of this surface be 0 to 100, 0 to 100 in the u direction, and 0 to 80 in the v direction. And now I want to trim this surface into 5 components in the u direction, something like this: 1, 2, 3, 4, 5, and 4 components in the v direction. So for example, I have a domain of 0 to 100 in the u direction. So the start limit of this surface is 0 at this point, and the end limit in the v direction is at 100 at this point. Similarly, the start limit in v direction is 0 from this point, and the end limit is 80 in v direction at this point. So this is what a domain is for a surface in v, and it is the domain in u. And this point will have a domain of 100, 80. So suppose we divide it into 5 and 4 respectively. Now, if we want to evaluate the domain of, say, suppose this surface, so in U, this point becomes 20, this becomes 40, this becomes 60, this becomes 80, because we have 5 segments and the range is 100. So we divide 100 into 5, so 20, 40, 60, 80. Similarly, we have 20 over here, we have 40 over here, we get 60 over here, and the domain of this surface becomes 20 to 40 in u direction and 20 to 40 in v direction. Similarly, if you want the domain of this surface, it becomes 80 to 100 in u direction, in this direction, and in v direction, it becomes 60 to 80. So domain can be anything and everything. It can be starting from, this was example for 0 to 100, but it can be starting from plus to plus. It can start from minus to plus. It can be from minus to minus. It can be anything basically. So a domain of a surface is computed by the grasshopper itself using a component called bounds. So bounds is a component which gives the domain of the surface. So if you read it, it creates a numeric domain which encompasses a list of numbers. So if I set this and enter this, it creates a domain. But this domain is different from this domain. This domain is the domain of the entire surface. The isotrim component wants domain of all the individual surfaces. It wants the domain of this first surface. So it numbers like 1, 2, sorry, it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So it wants domains of all these surfaces to isotrim it. So it wanted the initial surface, and it wants the domain of all these surfaces. So to create a domain, there is a component called divide, divide, domain square. So this is the component divide domain square, and domain square is used because it has two directions, v and u. So always remember, when you have to isotrim it, you have to use the divide domain square. So now it wants 3 inputs. So the first input is the domain, which is actually this. So the domain of the base domain of the surface, so you can directly actually input the surface. So it actually automatically reads the domain of the surface. You don't want the bounds. And it wants a u count and a v count. So u count is the number of segments you want in the u direction. So let's set to 5, and let's set the v count to 4. And now if you read the output, you can see, I can enlarge it, you can see it created 20 different, because when we divide it into 5 and 4, it will create 20 different 5 into 4, 20 different surfaces. So this component created 20 different domains from starting from 0 to 41 in V in U and 0 to 100 in V, depending on the domain of this, and it created such domains for all of these 20 subsets. So it started from 0, ended in 19. That means it has 20 surfaces. By default, indexing starts from 0, and I want these segments as my domain. Now you see, if I switch the preview of this, You see the surface has been divided into these smaller surfaces. Now, if you want to evaluate, we have just 10 to 15 minutes left, so I would hurry up a bit and take. So if you want to evaluate the area for this surface, for all these individual surfaces, we can just input these surfaces into these geometries. So it gives two outputs. If I take a panel to read the areas of all the surfaces, you see it gives me 20 different areas starting from index number 0 to 1, 0 to 20. And it also gives me centroids. That means the physical geometrical centers of all these surfaces, which are these points on this actual surface. There's a command called point list, which actually helps you visualize the numbering of these surfaces, index numbering of these surfaces as it has been done over here. So if you input these centroids and these points, you see a number appeared, but it's very small. So using a number slide, you can increase the size of this. So you see, actually the referencing started from this point. So this is your first index number 0 surface, which has an area of 1133 millimeters square, and this is 1, which has 1737, and so on. Now suppose there's another option. This only gives the centroid. But now suppose if you want, suppose I go back to the sketch. The area component gave you a center point of the surface, but you want to evaluate, suppose, any other given point like this or this or this on a given surface. There's a component called evaluate surface. So what this component does, it evaluates the surface on a specific given point. So if this is 20 different surfaces and I want all the 20 surfaces to be evaluated at a given specific point, I input the surface and give this to this. But now it wants a point at which exact point you want to evaluate the surface. Suppose I want to evaluate it at this point. So for that, there's another component called MD slider. So what MD slider does, it actually makes your entire surface into this domain. Now, by default, MD slider has a domain of 0 to 1 in the U direction and 0 to 1 in the V direction. And this cannot be changed. It can be changed, but it is preferred to not change the domain of this and let it be at 0 to 1. But as soon as I input this in this, you see there is an output, but the output is wrong because the domain of these surfaces is not from 0 to 1. It's from 0 to 41, 0 to 100 in both the directions, and similarly for all the surfaces. So what you have to do, you have to reparameterize all the surfaces domain from 0 to 1. So to just reparameterize it, you just click right on this surface input, and there's an option to reparameterize. Now you see, as soon as I reparameterize it, it gave a correct output. So all my points is at 0.5 from 0.5, and as soon as I change it, so if I want 0, 0, you see all the points of all the surfaces are at 0, 0, 0, 1, 1, 0, sorry, and if I want at 1, 1 or 0, 1. Now this evaluate surfaces give five output. First are the points, which are these points. Second is the normal. Normal is basically the normal tangent. Suppose this is a surface and this is my evaluated point. So normal is basically a normal tangent perpendicular to the frame of the surface. Frame is the actual frame in which this point lies. This is the frame of the surface, which has a specific plane. This is the normal. and this is the u and v direction as output of this point. Now suppose you want to create circles on these points. I would just maximize this. You want to create circle. You see, that was a hexagonal black box. That means it only contains circle components. So you need to select this. To create circles, it wants two components, it wants planes. So planes are basically frames. So you see, it created circles on all the individual surfaces at that specific point. And now it wants a radius. So radius will be, suppose I say 15. We can set it the number slider. So these are the circles that is created on that frames, and you can actually control the size parametrically using this surface, or else you can control at which point actually the circle has to be made. Now suppose you want to make conical expressions on this surface, something like, suppose you made these circles and you want all of these surfaces to make conical projections in the 3D. So for that, what you need to do, firstly, we had a surface, we evaluated the point, a specific point, we made a circle on that specific point, and now this final step is to move this point in a perpendicular direction and use this circle and this point to make a conical expression. So we already did this step, we did this step, we did this step. The fourth step is to move this point, and the last step to actually extrude this circle to that point. So in our fourth step, to move that point, we actually use move component, which is used to move any geometry. So if these are my points and I want to move it, it asks for a motion. So by default, the motion is set to Z. So it is perpendicularly moved in the Z direction, but you want it to move in the normal direction of those points. So we can use directly this normal input to move it in the normal direction. Now this normal direction is a unitized vector. So to magnify the amplitude of this unitized vector, there is a command called amplitude, which helps us to magnify the amplitude of this. So suppose I want the same parameter to guide the radius and the amplitude. So I can input the same number slider in both of these, and this as my motion. So you see, all the points are moved in a perpendicular direction from those frames. And the final step would be to extrude these circles to that point. So there is an option for extrude. There are many options to extrude, but for now, we would just use extrude to point, extrude, extrude point, and it wants a base. So base is actually the circles, and it wants the points till where we need to extrude it. So these are the points. So you can see it make these 3D cones on each surfaces, which now can be parametrically controlled using the number slider of the radius, or else if you want to change the height, we take another number slider to change this amplitude. So you have multiple parameters now. So you can change the height of the cone, you can change the radius of the cone, you can change the location of the cone on these surfaces where you actually want it. You can create actually any shape, a cone, a cylinder, a tube, anything on these surfaces. You can also change the surfaces using these parameters. And this is how we start unrolling these geometries using a digital framework system, which can be done in this process. And you have created this script which you can use at any point of time in your design stage to actually manipulate it and want an outcome that you require for a specific thing. And now if you want to bake, so as I said, these are all visualizations in Rhino yet. So if you want to actually make these 3D geometries in Rhino, you have to select it. You can right click it, go to bake. So it says, we are sorry, but baking is not possible. Okay, so by mistake, I might have selected a command running in the Rhino interface. So I have to click escape. Now if I go to the bake option, it opens this dialog box. I want to bake it in layer 4, and there's an option to group it. So if I click yes, all of these cones will be in one single component. And if I don't select this, all of these cones would be individual. So for now, we won't select it, and we'll press OK. And we go to the rendered viewport, and you see all of these are individual cones that are baked, and now we can actually move it in the Rhino interface as well. We can also bake the surface. So this was our initial surface. We could right click it. I want this to be in layer 5. Okay. So the surface also got baked, and we will preview of all of these. We will minimize the grasshopper screen, maximize my viewport for Rhino, which is set to rendered viewport, and this is what we get. So yeah, this is it for today as a tutorial for our grasshopper. You can try this out, try this simple extruding it, and if you face any problem, you can unmute yourself and tell me. While then I will reshare my presentation to just have a brief overview of Parametricism 1.0 is. If anyone of you is trying out the geometry and face any problem, you can just unmute yourself and ask. Okay, so I will reshare my screen. So yeah, this was the introductory session of Parametricism 1.0, but we have more workshops planned after this, which are 3-day online workshops, which are covering varied domain of computational design and parametricism. The registrations for the same is opening on 17th of August, that is tomorrow, Monday. So we have 3 workshops in this session for this month, for the upcoming month, sorry. So the first workshop is on parametric facade and cladding system, which is on 4th, 5th, and 6th September. The second workshop is on form finding techniques and digital simulations. And the third workshop is on environmental analysis and how to use that environmental analysis data to create performative design solutions, which is on 18th, 19th, and 20th of September. So the first workshop, Parametric Facade and Cladding System, which is on 4th, 5th, 6th, focuses on designing parametric facade systems using plugins like Lunchbox, morphing, attractors, and of course, we would go into a greater detail of Rhino 3D software itself and a greater detail of understanding the Grasshopper interface and how more you can analyze your curves, and you can analyze your geometries using different techniques. The day-wise plan is also given in our website. You can go to, I will tell you the website name at the end. The second workshop is the form finding and digital simulation workshop, which is on 12th and 13th September, in which we will explore Mesh Plus, Kangaroo, Weaverbird, which are actually form finding technique plugins and digital stimulation plugins, in which we actually stimulate how a minimal surface, which was the initial technique used by Fryoto to develop minimal forms. Like for example, if like soap bubbles are created on this minimal surface concept, and the day-wise plan for the same can be found on our website. But this workshop is a 2-day workshop. The third one is the environmental analysis and performative design workshop on 18th, 19th, and 20th, in which we will be covering Ladybug, which is an environmental analysis plugin, Honeybee, which is a performative design plugin, and Galapagos, which actually indulges both of these plugins to give multiple iterations for a specific problem. So yeah, the registrations are opening on Monday, 17th of August. You can also register for all the three, which have their specific benefits. That is, you can get 30% off on till 25th of August, and after that 20% on bundle registration. You can register at epochindia.in/education. And yes, finally, I will request you all to just right now go to this website. I will share the link as well in the chat box at epochindia.in/help us improve, and fill a small feedback form so that I can improve on this service that I am providing. Yeah. So with that,